I'm going to share with you this morning some of the experiences that we've had in the UK of moving through digital transformation in the UK water industry. This is really exciting stuff. It's really exciting stuff because in the UK I have seen pictures, glimpses of digital solutions really improving asset performance management and customer service. I've seen that happen, which is great. And there's no shortage of technology suppliers who will offer different ways to help you do that, which is great. But the path to digital transformation of a water utility is not always a smooth one. Some of the UK water companies started a while ago and they're still not there. It's a journey that just keeps on going, and it has been a little bumpy. But I want to share some of those experiences with you so that you can learn from that, we can all learn from that, and we can get better. But before I do that, what I want to do is just give you a quick overview of my CV, my background, because it'll help you understand the reason why I've formed some of the opinions that I have. So, I started out my career in engineering, civil engineering. I was actually a wastewater hydraulic network modeller, and I spent 8 years doing that type of work, supporting the capital programme for our clients, helping them to optimise their capital solutions. After 8 years of doing that, I moved into operations, where I spent a couple of years managing a county for Severn Trent Water. Severn Trent are one of the largest UK water companies, and during that period I was responsible for day-to-day 24/7 management of the assets in that county and keeping the people safe who were doing the operating and the maintenance of those assets. That was a big responsibility. After a few years of that, I combined that engineering and ops experience and I moved into the strategy department of Severn Trent Water. In the UK, we have investment cycles, so my job during that period was to help them with their business plan. And part of that business plan was digital transformation. How were they going to get smarter? And one of the activities that went into that business plan was to create a smart wastewater network. So, when my time in strategy came to an end, I got the job of delivering the project that I had just put into the business plan, which was to develop that smart wastewater network. So I've learned a lot about the impact of digital transformation on a business over the years. I really have. And I think what I really want you to remember when I talk about this is that period that I spent in ops, because I have been on the receiving end of digital solutions that didn't work. And I've been on the front line of having to try to get the people who worked for me to embrace digital when they did not want to. So I know it's not easy, but we will go through some of the lessons learnt from the UK today. So the digital utility, the UK water experience. Then we'll talk about what a digital utility is, so some of the attributes of a digital utility. We'll then talk about how to become digital, so I'll take you through a high-level plan of that journey. And then I want to take you through some real-life case studies, transformations of different parts of a water company business that I've observed. So a little bit about the UK for those folks who aren't that familiar with the UK water industry. That is a map of England and Wales and Scotland and Ireland. The UK water companies serve 60 million people, 32 privately owned water companies, 2 government run. And since privatisation in 1989, they've invested over £130 billion in maintaining and improving the asset base. So those are some high-level figures for you. On these maps that you can see on screen, those are the combined water and sewage companies across the UK. So those companies look after water production, water distribution, conveyance systems, collection, and wastewater treatment. And we're seeing a lot of pressure on the water companies in the UK, pressures that I think you guys can probably relate to. We've got similar concerns around ageing infrastructure and the resiliency of the assets, the level of customer service that we're able to provide. There's a general theme of being required to do a lot more for less. So our next investment cycle is about to begin. Our next 5-year investment cycle is about to start. The amount of money to spend in the UK is £50 billion. £50 billion total expenditure for the next 5 years. That's exactly the same number as the previous 5 years, but the standards have all gone up. In addition to that, the third point there, common key performance indicators for UK water companies. So for the first time now, we're seeing the water companies all being judged against the same thing. There are 7 key performance indicators that include things like sewer flooding, pollution from the sewer, those sorts of indicators where all of the water companies are being expected to achieve the high standards of the upper quartile water companies. And they've got to do that for the same amount of money as was in the general investment plan in the last investment period. And to make it even more challenging, there are penalties if they don't hit these key performance indicators. So where they fail to achieve their targets, there's a total penalty over the 5-year period of over £4 billion. So challenging times, but those are the reasons why, or some of the reasons why, you will see digital in every single UK water company business plan. They have got to find ways of operating their current assets more efficiently because they cannot afford to build loads of new ones. That's the message here. So, what is a digital utility? What's a digital water utility? A digital utility uses data to help their organisation and people be more informed and achieve better outcomes. Data. I'd go further than that statement. A water company, a water utility, is actually a decision-making factory. That's what it is. Whether you're making decisions about which event to respond to, which alarm to respond to, which alarm to ignore, what asset to invest in, what type of investment to make in that asset, which customer call to prioritise, they're all decisions. That's the day-to-day life of a water company, and decisions need to be based on data. So, a digital water utility puts data at the heart of their digital transformation strategy. They build data pipelines and automate the collection of data so that it is slick. And they integrate that data so that the full business can get use from that data. They bridge the gap between all of the vendor-specific platforms that they have in place so that they're not constrained to only being able to analyse certain silos of data. And that opens up the possibility to start making some much more informed decisions. And of course, through digital technology, you can start to automate that. So you generate algorithms and clever rules that suggest an activity, whether that's shut a valve or invest in this or respond to that quickly, leave that one alone. Better outcomes come from this. And one of the reasons that better outcomes happen is because the system can learn. What I saw when I ran operations a long time ago was a lot of historic knowledge in people's heads. And the quality of the service that we gave on any given day would depend on who happened to be working. That's not great. That made me feel really quite, uncomfortable. With this type of system that I'm describing, when it suggests an activity, when it supports a decision, if it's correct, then the system knows that it was correct. If the decision that it was supporting, if the answer was wrong, then that gets fed back into the system. The algorithms improve. You don't get that when it's all going on in people's heads. So that is key to a digital water utility, putting data at the heart of it. And of course, what you can start to realise then are the massive advantages of working in this way across the full water cycle. Rather than your wastewater network decisions being based on wastewater network vendor-specific data, you can start to join lots and lots of dots. Data that's related to water production might actually be quite useful in the decisions that you're making about your conveyance system. These are the sorts of efficiencies that sort of data-driven approach can start to bring. And it's getting cheaper and easier. So this slide is showing the 3 waves of digital. You know, this is what we've seen. We've moved in wave 1 from, great, we've got computers, to wave 2, where we could start to network and communications improved. Automation started to become slightly more sophisticated. And now we're moving into wave 3, where it's all about big data, analytics, IoT. And the good news is that is becoming more affordable. So again, when I look back to when I was doing planning work, trying to help my water utility become more digital, data storage was really expensive. The algorithms were not easy to generate. It was a very expensive process to go through. That is not the case now. Storage is cheaper and analytics are a lot more accessible to a water utility. So that's good news. And of course, digital water utilities, they're integral to a smart city. So results from top 100 hyper-connected smart city studies show those improvements related to water. So 40% improvement in public health, 37% improvement in reliability and resilience, 34% reduction in pollution, and a reduced water usage of 29%. That's fantastic. What underpins those statistics are things like real-time water quality monitoring, smart metering, and proactive and predictive maintenance. You achieve those numbers through knowing what your assets are doing and responding before it results in a failure of service to a customer. So, moving through how to become a digital utility. Right, I'm going to go with a caveat now. There is no right answer to this question. And if anybody tries to tell you that there's some magic blueprint that you just follow and you will be magically transformed, that's just not true, because every business is at a different stage of maturity. They all have their own specific challenges. But what I'm going to do is just take you through some guiding principles. The first message with this: fundamentally, when you're visioning your digital transformation, you need to try to break away from the idea that it's just a collection of technology projects. It is not an IT technology project. That's the most important lesson, I think. We start in stage 1 by doing that visioning piece. So what does the water utility want to achieve? There's loads of technology out there. You don't necessarily have to use all of it. There might be some things that aren't really hurting you. There are going to be some things that are specific to your organisation that you think, yeah, we really need to hit that. No, we don't need to worry about that right now, but we can put it into the long term. So that's where you do your visioning and you start to do your gap analysis. I'll show you a little bit more detail on that in a minute, but there are certain criteria that you look at within a water utility and assess a level of maturity, draw up a plan of where you want, how you get to where you want to go. And we start to build the use cases. This is where the second most important principle comes in: people. People will be at the heart of a successful digital transformation. And that is for 2 reasons. First reason, you've got to be able to implement that digital solution. It is not good enough to just create stuff that's clever and expect people to want to use it. You have got to bring the end user into the development of those solutions. And more importantly than that, you've got to bring the right end users into the development of that solution. So ideally, you will select representative, that's better, representative, influential end users. So when again, thinking back to my ops days, there were guys and gals who were in my ops team who had some influence. Get them involved in the development of your digital solutions. That will work much better. Secondly, analytics. A lot of what is done is automated, but you absolutely have to find ways to incorporate the domain knowledge into the analytics. This is one of the prime reasons that the digital transformation journey has been so bumpy in the UK. There was a focus on this being a collection of IT technology projects, and all of that knowledge that sat within the business in people's heads was not incorporated into the evaluation and testing of the analytics. And again, if people are involved in the creation, they're more likely to use it. So people, really important. Third, architecture and data model. There is no doubt the technology underpins all of this. You need to have the right IT folks, OT folks, part of that end-to-end team who are going to deliver those different elements of digital transformation. There is usually a procurement piece. So a water company will have to go out to new vendors to supply some of these different services, and the implementation of that, so how you start to actually create the services and manage the performance of them. So in the same way as your smartphone keeps getting smarter and the apps keep getting better, digital transformation in a water utility doesn't stop. The customers know, the customers are very well informed on what's going on in digital technology. They can see it when they pick their phones up. So they're going to expect you guys to keep moving. Just don't expect to just get there and tick, done. It will take a while. So this is a collection of criteria, example criteria that we would look at when we're establishing how mature a water company is, a water utility is. So first of all, at the top, how advanced is the strategy and vision? How much thought has gone into creating that? Where's it at? What sort of level of sponsorship has it got? Is there a business structure in place to really drive this through the business? Because it's not easy. The utility uses the information to enhance resiliency. Really, the question is, how easily is that data being used to improve resiliency? Is information being used to optimise workforce management and develop the new skill sets that are going to be required over time? Is information used to manage assets? So, how well is that data that you're collecting going into a consistent asset management type approach? The utility data collects, maintains quality and security of data and transmits it to proper points for analysis. So that's around the infrastructure of how it's done. Systems managing the performance are integrated across the organisation. So again, what we're talking about is breaking down the silos in the water company business and just creating data that anybody can access for whatever reason it might be useful to them. And then data analysis methods are used to produce useful and actionable information. It's not good enough to just do amazing analysis. You've got to have the infrastructure in place so that the business can act on it easily, not sit for hours trying to work out what the right spreadsheet is and how to interpret it. So, that was a bit of theory. We'll now move on to some case studies. So this is an example from South East Water in the UK, where we help them with digital transformation of the water distribution system. So South East Water have got very, very tough leakage targets, as many of the other water companies have. They serve a population of 2.2 million people. They're already on the journey to being smart. They have a network of sensors and the processes in place to do something with the data, but it wasn't working well enough. So they looked at moving up that level of maturity. Specifically, they wanted to be able to identify where a leakage repair was required and prioritise it, because one leak is worse than another. One will have a really bad impact on customers, the others won't. They also wanted to be able to reduce the cost of detection, again, through automation, and they wanted to reduce spend on repairs. So repair the leaks that mattered. Don't just repair everything straight away. It's just not an efficient way to operate. So what did we do? Well, we worked with South East Water on a programme that tested the latest sensor technology. We were working with 9 different suppliers to look at what sensors gave them the best outcomes in the different scenarios that they were placed. We unified the data. So remember what I said about vendor-specific platforms? In this particular activity, we unified that data so that all of the data was in one place, very powerful. And we managed the collaboration between those 9 specialist suppliers. This was a pilot that we did with South East Water. And the learning was, well, we learned exactly what we hoped we would. We learned that there was a better way to do this. Great. We also proved that we could meet those problem statements. The prioritised response was faster. We could predict events more effectively, and we could improve the customer experience, because it's really useful for a customer to know whether they're going to be off supply for 1 hour or 12. Analytics can help us do that. And we learn a lot of technology lessons too. And this just gives you a little overview of the types of things that I'm talking about. So when I'm talking about monitoring of a water distribution network, we've got collections of water meters, we've got sensors that are managing water quality and pressure, we've got acoustic loggers that are out there trying to detect signatures that might indicate leaks. The data's transmitted back into the platform that's now taking 9 different vendors' data, and we process that. So really nice example of how we took the water utility through that journey. And now over to Jonathan.
Thank you.
There you go.
So for those who don't know me, I'm Jonathan Fitzpatrick. I'm the Chief Instrumentation and Controls Engineer for North America, and also the North American Sector Lead for Digital Solutions. So deploying a lot of what we're talking about in the UK, in the North American market as well. So if we take it back to this side of the pond, we have a case study from Atlanta, where they were having a number of similar issues going on in the UK, a lot of sewer overflows that were affecting the problems with aging infrastructure, significant improvements, and a significant capital program that they need in order to sustain their infrastructure and respond to their population growth. And they are looking at ways to reduce their operational costs, and they were looking to digital solutions and analytics to do that. So the approach here was to find an easy win use case, and that was sewer overflows. They were spending on average about $200,000 every time their sewer would overflow, and anywhere from 100 to 200 overflows were occurring in a year in various regions within Atlanta. So it's a very significant cost associated with doing that, not to mention the publicity around this as it's affecting the citizens of their city. And we have a video from the city manager. He was actually on the news to show how great this system was.
New technology is saving local taxpayers hundreds of thousands of dollars. Channel 2's Dave Huddleston reports how a group of city workers came up with the idea that prevents sewage spills.
Look at Crosby, it's actually alerting right now.
Atlanta Watershed Manager Patrick Woodall is on the phone after receiving an alert that one of the city's 1,500 miles of sewer line is clogged.
Have them text me and let me know what the results and what they see.
In 2012, Atlanta experienced the largest sewage spill in its history and was fined more than 100,000 taxpayer dollars. In 2013, Woodall and his staff developed a computer program that tracks all of the city's sewer lines and uses that data to not only monitor levels, they can track unusual readings, similar to unusual credit card usage. We follow Woodall and his crew to this trouble spot, a raised manhole in a backyard in northwest Atlanta. They're able to unclog the line and stop a spill before it even starts.
Had that not been in place, this would have surcharged. You can look around you. This is an area where kids or animals, pets would have been playing.
With that computer program and 280 monitors, Woodall and his 9-person team have prevented close to 50 spills, including this one.
It's a victory to me. It's something we stopped.
Saving money at the same time. In northwest Atlanta, Dave Huddleston, Channel 2 Action News.
There's some really interesting takeaways from that, and they actually installed a very large set of sensors associated with this, and it really goes to this IoT revolution that we're seeing. So the cost per sensor was extremely low. The total installed cost was about $1,000 US per site. It was about $1,000 per site. So, and that was for the instrument and the installation and labor associated with that. And it takes advantage of just the type of sensor technology that you can integrate by going to an IoT infrastructure. It was tied into the municipal Wi-Fi network, so another very low-cost way of getting that data back into the system. It was also interesting, so they had this analytic that they were running in order to predict where the overflow was going, but they were also able to take historical data and run it through the analysis. Because they actually had some capital spending in place, about $15 million that they had negotiated with the EPA to go in and to address this issue because they were having problems with overflows in a few of the neighborhoods. So when they ran the historical data through the analytics, they actually showed that the capital program was in the wrong location, and that they actually didn't have a sewer overflow problem in that area, and that they needed to address it, and they needed to spend that money somewhere else. So they were able to go back to the EPA and defer that $15 million and focus on a digital approach and focus on upgrades in other areas. So it not only did it help them operationally, but it also informed their capital program and working with EPA. EPA were pleased that they had the data available to show them that this was a viable solution. So, a few takeaways from this. They're, because of the success of this first rollout of their digital solution, the sewer overflow, the City of Atlanta has now taken it one step further, and they've decided to do a digital transformation project. And they're moving towards this one water vision. So integrating their systems together, a lot of, like what Joanna was saying that they're doing in the UK, integrating these disparate business units together, creating these data lake layers that will allow them to do the analysis across business lines, improve their operations, and compliance and all these other issues that they're having in the city. Back to you.
Thank you. Thanks. So as we've been on this journey of helping lots of different clients, we've had to help them solve lots of different problems. So what you can see on screen here is our periodic table of some of the different data analytics that we've created over the years to help our water companies, our water utilities meet the different challenges that they're facing. So you'll see some in there: energy management, pressure optimization, prediction of events, anomaly detection, so where we want to spot where an asset's starting to fail, those early signs. So I'm just going to give you some examples of some of those now. Before I give you the specific examples, I just want to point out that this is the general architecture that we use. Because all of our clients are in different places along their digital journey, we have to be very flexible in the way that we can help them analyze data. So this is the solution that we use. We use a Microsoft Azure-based architecture that allows us, we'll move from left to right on the screen, that allows us to take sensor data from any platform, open source as well. We always, I can't think of an example where we haven't really used weather data, as well as other types of open source data as well. So in the cloud, we can ingest all of that data and we can start to process that data, and obviously it's stored in that second column there. And then moving over into the third area, the analysis section, there's any number of approaches that you can use to analyse data, from very basic analytics through to more complex machine learning. We choose whatever is going to work best for the client, and whatever solution can be incorporated back into their system most effectively. And I think this is a really interesting message, because everybody can get a little bit caught up in the buzzwords of artificial intelligence and all this, sort of supercomputer, amazing science fiction technology levels. This is what people start to get really worried about. But actually, you can achieve an awful lot with relatively basic analytics and complexity that you need to as and when required. So that's the learning that we help our clients to go through whilst they're getting their systems and moving through their own digital transformations. We can keep the wheels on the bus, help them start to meet some of those key performance indicator challenges whilst they're getting their enterprise architecture sorted out. And we output that in any number of ways. So that could be output as a sort of web-based interface where we show the results of the analytics in a dashboard, or it can interface back into the water utility system. So that's how we help develop the solutions. And this is an example. So several UK water clients, because of the common KPIs, several water company clients have got really, really tough challenges around reducing the amount of sewer flooding that occurs. So every water company is expected to reduce the number of incidents where sewage enters people's properties. And some of the reduction targets are absolutely, they are going to be very, very challenging. Several of the water companies have got to reduce their numbers by more than 50% in the next couple of years. That's some big numbers, and there's big penalties associated with not meeting that. So how did we help our clients meet that challenge? Well, again, we knew that they needed visibility of what was going on, and a lot of this flooding from the sewerage network was occurring quite close to people's residential properties. We needed visibility of what was going on, basically at residential level. So we ran a pilot where we are installing 4,000 small sensors across the network at residential level, so that the water company can start to gain that visibility of where the sewers are starting to block, and there's an increased risk of flooding. That's what the sensors are there for. 4,000 sensors is a big number, and there's a concern that the control room would be overwhelmed with alarms that were now coming in from these 4,000 sensors. So they needed analytics to process all of that data and really extract out the alarms that look to be blockage related, not the alarms that are just triggering because the sensors are struggling with the environment that they're in. So the results that we expect from this trial will be an incident reduction and an improvement in customer engagement. We've already seen that in some of the trials that we've done for the water companies. Customers love it when you turn up at their property and you say, "We think there's something about to go wrong, don't worry, we're here to fix it." That is so much better than, "Hi, we're here, where do you want us to start cleaning up?" It transforms the way that you interact with your customers. And we start to get a better understanding of what's happening across the system, where the assets are, what the patterns are, which areas are we more likely to have these problems in. And throughout that whole journey, we're demonstrating the value of analytics, because it was analytics that chose where those monitors should go in the first place. Using risk-based machine learning modelling, we selected the locations, and now we use analytics to process the data too. This is a similar example, but a slightly different slant. So this is CSO application. So this is where we are helping our clients reduce the number of CSOs. Again, talking to the end users, we understood that one of the primary concerns was overload of the control room. The water utilities need to put more sensors out. They do not need loads of noise in the control room from all of this new sensor technology. So the first thing that we developed was an analytic that could verify the data. So in this particular example, what you'll see, we've got a GIS view on our dashboard, deliberately nice and simple so anybody can understand it. We've got a little GIS view, and each of the sensor locations would be colour-coded according to their status. So if this was operating in real time, you would see some at red, which means something bad's about to happen, amber, which means, prepare, and green, which means everything's fine at this location. So you would see that colour coding in the GIS view. Then in the centre of the right-hand panel, that is where you can see the number of overflows being counted. So each time that overflow activates, it increases the spill count. In the bottom right-hand corner, this is our rainfall that we're using as part of the analysis. And this little time slider just allows us to move around the time series data and see exactly what's been happening over time. In this particular example, the telemetry, I think that was about 5 o'clock in the morning in December, the telemetry fired in an alarm saying that an overflow was occurring. We know that it wasn't. The analytics have processed that data, and that alarm was not real. An experienced person in the control room would also have known that that alarm wasn't real. But we can automate that and make it more consistent. So that's what we've done. The telemetry alarm will have been ignored. We could, with high confidence, advise operations that they didn't need to do anything. They didn't need to notify anybody. They didn't need to respond. Fantastic. And this is an example of an asset that's behaving itself, which is great. So this one, we can see that our spill count is jumping over time. It's about a 2-week period. It's jumping from a spill of 24 up to a spill of 29. So 5 spills, 5 overflows. And in the top here, the top right hand of that visual, that's the basic output of the machine learning. That's boiling down the analytics to a really simple, how likely is it that that overflow should be operating in a percentage term? Really easy to understand. So each time that spill count jumps up, you see a corresponding spike in the prediction. The analytics say, yes, this overflow should be happening. You don't need to worry about it. This one, a different story. So in this particular example, we've jumped from a spill count of 20 to 23 over that period of time. And the model is telling us that the likelihood that a spill should be occurring hasn't exceeded 30%. In fact, it was 0% at some points. So we know that there's something wrong there. We know that somebody has got to get out there and respond. The advantage with these analytics is not just the real-time operational response, though. That's a big part of it, yes. You want to get out there and stop the bad thing that's about to happen. But the results of this analysis are there for anybody to access going forwards. So if you're the operations manager who wants to know what one of those sites is, what it's been doing this year, you can look. If you're the person in strategy who's trying to put together a business plan and deal with the regulator and talk about how often these overflows are occurring, you know how many times it's spilt because you've taken out the false alarms and you know why. That's really useful. Really, really useful. And then when it comes to your asset management process, when you're trying to decide whether a capital investment or an operational investment or no investment is the right thing, you've already got a load of analytics that were done in real time that tell you whether the thing should have operated or not. You're not commissioning loads of separate studies. Very, very efficient. Sentiment analytics. There you go.
Thanks, Joe. So one of the other analytics that we've been looking at is around customer engagement and around customer sentiment. So what we've done is developed an analytics package which will consume social media data. So it ties in with Facebook, ties in with Twitter, and it will give you the customer engagement score, trending topics, customer issues, and very importantly, the location that the issue is occurring in. So what we've seen actually, and a lot of the test data that we've used, and we pulled some data from LA, where there's a lot of people on Twitter. And there'll be a sewer burst, there'll be an overflow, and they're on Twitter saying, hey, LADWP, like there's a burst at the corner of this and this. And that comes in before the SCADA system realizes that there's a burst. So we can tie that in with the asset, and we can tie it in with a region, and we can show that there are issues. We can see issues with billing that might be occurring, just general sentiment around the utility, and whether it's positive or negative in any given period of time. You can see, you basically use all of the citizens within the city as part of an extension of your SCADA system and pulling that data in. So phase one is what we're developing right now, which is just taking that sentiment, going through natural language learning algorithms, and deploying the issues on the GIS map, looking at who are the influencers in your area, right? Who are the most active people that are contributing to the list, the occurrence of issues, and then coming up with an overall sentiment score that we can look across utilities and see generally whether it's positive or negative. Phase two, the plan would be that this actually gets tied back into assets, ties back into the SCADA system. So you would actually be able to say, okay, our citizens are saying there's a burst at this location. We actually think that that's a result of this other analysis that we're doing, say using the SCADA data. So we can tie that in as another point of information back into the system. So this is an interesting way of interacting with your end customer. We're finding that there's a lot of emphasis on customer engagement at that local level, and it's a great way to see where we're trending as a utility. And to wrap all of this up, we are currently actually doing working with the Water Research Foundation and leading the Digital Utility of the Future framework. We'll be developing sets of criteria, framework for what a digital utility is. We've got a number of utilities across North America, and I think a few international ones as well, that are going to be working with us. There is still an opportunity if EPCOR and others would like to join. If so, just let Joe and I know, and we can bring you in. But the whole idea is to come up with a common framework based on the feedback that we get from utilities and people that they serve. Joe?
Right, okie dokie. So, key takeaways from all this. I just want to leave you with some of the messages because I know I've given you quite a lot of information this morning. So when you leave here, these are the 4 things that I hope that you'll remember. First of all, digital transformation is more than a collection of IT technology projects. That is crucial. Involve your people. They need to be at the heart of the transformational process. They need to be involved in the development of the solutions, not just consulted as end users. Data-centric architecture will stand the test of time. So you might have to come up with strategies where you're moving in parallel and you're implementing solutions now to solve problems now that are maybe limited to certain vendor platforms. That's fine, but have a long-term vision that is really moving towards having that data lake, having that data in one place. It will serve you well in the long run. And then finally, digital transformation is a journey. I've stood up here as somebody from the UK to talk about digital transformation, but I don't want any of you to be under the impression that we have absolutely nailed it, because we haven't. You know, to be honest, some of the water companies that went first have had the bumpiest ride. There's been so much learning, and they are all continuing to try to move to a point of being more digital. So, how can we help you? Well, this is the way that we help our clients. We've got a global digital water delivery team, and those are the types of folks that you would expect to be involved. If you're working with us to develop your digital solutions, these are the folks that we would be drawing on from around the world. System architects, data scientists, analytics experts, business transformation professionals, and operational technologists. Now, you can go and hire in those roles, but the advantage that we have at Stantec is that we have already brought that group of people together. They all speak their own different languages, but over time that group starts to talk its own language. They get what each other means because they've worked together so many times on these types of projects. It makes the delivery more efficient. And of course, we've got a load of water and wastewater domain expertise that we can build into those analytics. And this is the type of approach. I've already mentioned this, but what we will often do with our clients is move through several pilot phases in the areas that are of challenge to them to help move towards that overall digital transformation goal.
Okay, well, thank you, everyone. That's time for the presentation. Joe and Jonathan are here all morning, so if you want to stick around and ask some more questions face to face. So thank you, guys. I appreciate it.
Pleasure.
Thanks.